Good morning, ma'am. Myself, Maitashri Sai. Today, I am going to give the presentation on the topic of asymptotic notations, review of functions and summations. Asymptotic complexity. Running time of an algorithm as a function of input size n for large n. Expressed using only the highest order term in the expression for the exact running time. Instead of exact running time, says describes behavior of function in the limit, written using asymptotic notations. Asymptotic notations defined for functions over the natural numbers. Describes how f of n grows in comparison to n square. Define a set of functions in a practice used to compare two function sizes. The notations describe different range of growth relation between the defining function and the defined set of functions. Notation for function g of n, we define g of n big theta of n as a set. Intuitively, set of all functions that have the same rate of growth as g of n. G of n is an asymptotically tight bond for f of n. Notation for function g of n, we define big theta of n as a set. Technically, f of n, g of n, old usage. I like f of n and g of n are non-negative for large number. This is an example. 10 n square minus 3n is equals to n square. What constants for not C1 and C2 will work? Make C1 a little smaller than the leading coefficient of C2 a bigger. To compare order of growth, look at the leading term. So in the example, 3n cube is how about 2 power 2n for function O notation for function g of n, we define O of g of n, big O of n as a set. Intuitively, set of all functions whose rule of growth is the same or lower than of g of n. G of n is an asymptotic upper bound for f of n. Example, any linear function a n plus b is in O of n square. How? Show that 3n cube O of n power 4 for appropriate c and n naught. Omega notation. For function g of n, we define omega g of n big omega of n as a set. Intuitively, set of all functions whose rate of growth is the same as or higher than that of g of n. G of n is an asymptotic lower bound for f of n. Example, root n is equals to omega n. Choose c and n naught. Relation between omega. In practice, asymptotically tight bonds are obtained from asymptotic upper and lower bonds. Running times. Running time is O of f of n. Worst case is O of f of n. O of f of n bound on the worst case running time. Running time of omega, best case is omega f of n. Example. So insertion sort takes place. Any sort algorithm must look at each item. Asymptotic notation in equation. O notation. For a given function g of n, the set little o. Next, for given function g of n, the set little omega. Comparison. This is the comparisons. Limits. These are the limits. Properties. Transitivity and reflexivity. In the properties, symmetry and complexity. Complementary. Common functions. Monotonic. Exponential. Use exponential polynomial. Logarithms. So thank you, ma'am, for listening to my presentation. Have a nice day.